Hello there, Paul back with a quick print project, not necessarily PrintShift related. I'm mostly waiting on parts to do more work on the part ejection systems, but I wanted to keep making videos in the meantime to build my skill set here. Today I'm presenting a quick, awesome printing project. Gutter-mounted solar lithophanes to make your house look awesome. Dog, the Remus dog. In true PrintShift style, we'll show you how to make your own, run you through the process, and then dismantle one of the lights to see how they work. Reasons. Get a better look at this. A lithophane is literally rock art. Originally these would be carved or stamped into rock or ceramic. The art form dates back long before 3D printing. It's also one of the easier personalized parts that you can print. This image is from The Nightmare Before Christmas. The animation makes them come out nice and clean, but it works very well with your own photos as well. Also got my cat Nettie and dog Remus. A better shot of the Remus dog. They really pop when the light is out. Keep the same image when I turn the light back on, and you'll be looking at the surface instead of at the light transmission. The way the lithophane works is by varying the thickness of your printed shell. Do want to point out one more. The surface of the moon, I did not make this guy, I just simply 3D printed it, but you have the correct surface of the moon, and on the inside, the part varies in thickness. So the moon surface is actually the actual NASA map thereof. But if you look at the inside, the thickness is varied so that you have, the craters are dark, even though the crater is actually a dent. On the inside, find a big crater. Yeah, the crater is a decent hole on the inside. The crater is also darker, so there's an even thicker layer of plastic behind that guy. And this was not printed on my PrintShift Prusa Mini because it's bigger than a Mini. Also, go Bears. So, what do you need to follow along exactly is one of these solar gutter lights. Solar panel on top. I also highly recommend that you get a new battery for these. Like most solar projects, they're running on a nickel metal hydride battery, 1.2. You can just buy any sort of decent brand name, because the ones they put in here are the, most inexpensive ones they can find. Let's have a look, actually. Vipow. So this one is 1200 milliamp hour. The replacement I got are 2300. I just sort of picked a number. It's more just to have a battery that you can trust and that you know where it came from. It came charged. One thing that really makes the project pop is adding a diffuser. This is actually a fairly difficult part to print. The secret is to increase the extrusion width. So even when you're using a 0.4 nozzle, I set the extrusion width to about 0.6, and then you can print a single wall part. And this is just designed to just knock right in here. Locks into that hole. Part is up on Thingiverse, so you can just download and print it. Other things you need, a picture you'd like to print, and of course a 3D printer. I'll be using my PrintShift modified Prusa Mini, which is just a stock Prusa Mini that has a part ejector on the bed. If you're interested in the part ejector, you can check out the other videos on this channel. Onwards, switch over to the Lithophane Maker. There are more than one online lithophane making tool. I like this guy for the spheres because it adds in, it lets you add in the lip and a little bit of parts so that you can just jam it right on there. Another one I want to call out, this is the lithophanemaker.com. There's also It's Litho, which has a little bit nicer web app, especially with the image modification. You can tweak the settings so that you get a better grayscale image for your lithophane. Lithophane Sphere Maker, doing a picture of Scarlet, Hillbilly, and Grandma. Daughter, horse, and grandma. Lithophane resolution, I usually drop that a little bit. All the spheres I've made are the default 140mm diameter. Maximum and minimum thickness, those seem to work fairly well. If you make it thicker, you can get more detail, but with the brightness of the light, you'd want a brighter light for a thicker lithophane, since you're blocking the light with the thickness. Outer diameter of the cylinder, that's right here. You can see there, cylinder thickness, outer diameter. Really nice explanation of what you're going to see and how it's going to look. Cylinder height, that's just this. I found that works fairly well. Oddly, there's no setting for the inside of the cylinder, so in order to determine that I want an outer diameter of 90 and a thickness of 4mm, I just grabbed this guy and measured. And like most injection molded parts, this is actually tapered up the side, so it's a little bit thicker, about 83 millimeters at the bottom and 80. So an 82 millimeter diameter gives you a nice jamming function interference fit. You could also easily throw some silicone sealant on there to make sure it doesn't pop off, but I've had one on my roof for a few months at this point. Hasn't fallen off yet. So top hole outer diameter is this little hole. I like leaving a little hole there so that you don't have a part of the print that doesn't look as nice. Important settings is when you flip the image, it's going to come out upside down, and this box here is showing you what is going to be on your globe. So I'm doing the fit image to sphere. Don't do that, then you'll have the entire image on there, but it's only going to take up 161 degrees around the globe. So you'll have half of the globe pretty much uncovered. You can also choose so I've done this on a fair number of them, and then you get 2 pictures on the sphere. You don't do that. Have to do the same picture. The X shift and Y shift just to show what's actually in there. So you make sure that you have what you want in your preview. I really like the tree. Just want to capture more of it and cut off a decent chunk of Hillbilly's legs there. Create the STL. Takes it a few seconds to generate and download. These guys call out also have a Patreon page. Totally go if you're using this extensively, which I recommend you do. It's a great tool. Support them. Follow on YouTube. Become a patron. Good thing to do. Once you get that down, Prusa slicer. I have a setting for a 0.15 millimeter layers on a lithophane. Only thing we're changing here is lowering the layer height. They do recommend a 0.1 millimeter layer height, which takes a lot longer. I have difficulty telling the difference. It's not the 0.15, but you will get a slightly smoother lithophane. If you're doing something for your desktop where people are going to handle it, more of an issue. This is going to be up on my gutter, so I think we can get away with a bit faster print time. Infill must be 100%. And I do add quite a large brim to make sure that the parts stay put on the bed. Rather long prints, and since it's 100% infill, if there's any issues on the bed, any over extrusion, you can easily knock the part free. It shouldn't happen, it probably won't, but I like to wear the belt and the suspenders to give it the best chance to succeed. When you download from the Lithophane Maker, you're downloading a zip file, which has a text file of the settings you used, as well as the STL file of your lithophane, which is really nice to save so that you can redo it or adjust it as needed. So you notice the image has been inverted. I want my subjects to be sort of in the middle, not too high. I'm pretty happy with that. I think it's worth a print. Slice it. The slicing is going to take a little bit because it's a very high quality print. Low layers, 100% infill. I'll take a look at it, send it off to the print server. So that looks decent. We are still generating G-code. Alright, slicers have come back. Take a quick look at your part. Notice that the walls are never more than, or never less than 2 layers thick. I'm going to export that. I've got my 3D printer up on Octoprint. I'm currently printing the previous Legoland double wide, so I'll throw that as a time lapse at the end. I was thinking we could also throw a time lapse up of the Scarlet and the horse. I'll throw that up on Twitch as soon as the video goes live. I'll start the print, so if you're around for the next 2 days after it's posted, you can watch it printing live, if that's something that excites you. Upload that, and then we're just going to click the queue here to add it to the queue, and that adds it to our continuous print queue. So our Legoland double wide is currently printing. Scarlet Hillbilly will automatically print when it's done. I'm actually going to remove it from the queue because I want to start it when this video goes live. Normally you can just queue up a bunch of stuff. While that's printing, I do want to open this guy up. Just show people how the solar parts work. You don't need to take this guy off. Got your LEDs. These do have an on-off switch. You'll notice that when you cover up the solar panel, it turns on. So they're using the solar panel itself to sense if it's dark enough to light up. We'll turn that off so we don't blind ourselves. This thing's held together by 3 tiny Phillips screws. Do be careful not to lose them. One other thing, they generally have I forgot to remove the screen protector. They do work fine with it on there. I'm sure it's blocking some light though, so you might as well take it off and get a little bit better solar power, a little more. 3 screws to hold this guy on. Careful of the wires because we have the solar panel. See, there's a ring of Celastic in there. This is just a ring of silicone. And that is your water seal. So if these fail, it's usually because water seeps in here and starts getting on the batteries or the electronics, which are actually screwed in, which is honestly a little surprising. Figured they would just be a press fit or something. 2 really tiny screws. And this is the battery compartment, so there's your battery. A single-sided circuit board. You got a resistor, 3 LEDs, your switch, and what I would assume is a tiny LED driver with a switch on it. I just like looking at the circuit board, so you can see the power from the solar panel comes in to that 4-pin IC. It's routed straight to the battery and to the switch. When the switch is on, you have positive power here going through the resistor. The resistor is there. That's just limiting the amount of current to the LEDs so they don't shine too brightly or overheat. Negative line goes directly to the battery. Negative lead from the solar panel goes to the negative on there. Because we can't be providing power with this pin. That's just telling you if we're on or off. Oh, I guess that tells you if you should be sending power to the lights at all. So it knows. That is a 5252F. I did look that up before, so I pulled up the data sheet. So this is SPAT, BAT. Next guy is VSS, ground line. Ground. All the grounds are tied together. And last is the drain of the switching power MOSFET. So this is where power is going. So this is how the power gets to the LEDs. But in any case, how they work, how these guys work, and just a really quick and easy 3D printing project. Make great gifts for folks. So you get a lot of people with the new 3D printer, they don't quite know what to print. Highly recommend you try out some lithophanes. And if you do dismantle some low-cost electronics like this, all these screws are self-tapping. They do not self-tap all that many times, so go easy on them. Before you screw it back together, turn it on, see if the circuit still works. If you made a mistake, better to find out sooner rather than later. But thanks for watching. I'll throw up a time lapse of this whole print once she's done. I'm not going to zoom in on the screenshot there because we'll get better resolution if we get it off the Pi, I believe. And as always, happy printing. Stay tuned, we'll do more PrintShift hardware builds soon. A little trouble with shipping, getting parts in, making sure we have everything we need before we get started. But happy printing.